Okay, so we'll start with miscellaneous exercises of limits and derivatives. So for the first question, we have to solve with first principles. Okay, so the first sub question is we have to find the derivative of minus x. So we know that the first principle is given by limit h tends to 0 f of x plus h minus f of x whole divided by h. So if we substitute f of x, limit h tends to 0 minus of x plus h, minus into minus will be plus x divided by h. So this is nothing but limit h tends to 0 minus h divided by h. This is nothing but minus 1. Second sub question, we'll have to find the derivative of dy dx of minus x whole to the power minus 1. So this is nothing but limit h tends to 0 f of x plus h minus f of x divided by h is given by limit h tends to 0 minus 1 by x plus h minus of minus 1 by x whole divided by h. So this is given by limit h tends to 0 1 by h multiplied by minus x plus h divided by x plus h into x. So on simplification, minus x and plus x will be cancelled. What's remaining here is 1 by x square, and h will be cancelled. So this h tends to 0, so x into x is x square. Third sub question, d by dx of sine of x plus 1. So this is nothing but limit h tends to 0 sine of x plus h plus 1 minus sine of x plus 1 whole divided by h. So we know that from the trigonometric identity, sine A minus sine B is given by 2 cos A plus B by 2 into sine of A plus B by 2. So if we substitute according to this identity, we will get limit h tends to 0 2 cos A is x plus h plus 1, B is x plus 1. So if we add these two, we'll have x plus h plus 1 plus x plus 1 whole divided by 2 into sine of, this is A minus B whole divided by 2. So we'll have x plus h plus 1 minus x minus 1 divided by 2. So whole divided by h. So we'll have limit h tends to 0 1 by h into 2 multiplied by cos 2x plus 2 plus h whole divided by 2 into sine of h by 2. Because x and x will be cancelled, minus 1 and plus 1 will be cancelled. What is remaining is h sine h by 2. So we'll have limit h tends to 0. We'll send this h as well as this 2 to the denominator of sine. So what's remaining here is cos of 2x plus 2 plus h divided by 2 into sine of h by 2 divided by h by 2. So limit sine x by x is nothing but 1. So the remaining answer is cos of, if we apply the limit, we'll have 2x plus 2 plus 0 divided by 2. That is nothing but cos of x plus 1. A fourth sub question, we have d by dx of cos of x minus pi by 8. So this is nothing but limit h tends to 0 cos of x plus h minus pi by 8 minus cos of x minus pi by 8 whole divided by h. So we have cos A minus cos B is given by minus 2 sine A plus B whole divided by 2 into sine of A minus B whole divided by 2. So this is given by minus 2 sine of uh, so the limit will be equal to, so this will be equal to limit h tends to 0 1 by h, I'm just taking the denominator h outside, minus 2 sine of A plus B. A is x plus h minus pi by 8, B is plus x minus pi by 8 whole divided by 2 into sine of A, that is x plus h minus pi by 8 minus B, that is minus x plus pi by 8 whole divided by 2. So we'll have plus x minus x gets cancelled, as well as minus pi by 8 and plus pi by 8 also gets cancelled. So what's remaining here is limit h tends to 0 sine of minus sine of x plus x is 2x plus h minus 2 pi by 8 whole divided by 2 into sine of h by 2 divided by h by 2. I'm just taking this h to the denominator here, as well as the 2 in the denominator of the denominator. So this whole term will be tending to 1 if we apply the limit h tends to 0. So if we apply the limit, now what will happen? Minus sine of 2x minus 2 pi by 8 whole divided by 2. Now if we cancel off 2, the remaining answer is sine of minus sine of x minus pi by 8. The second question is, we have to find the derivative of x plus a. So that is x is, we are differentiating with respect to x, so the a will be a constant. So the differentiation of a constant is 0 and differentiation of x is 1. Third question, dy dx of px plus q multiplied by r by x plus s. So this is given by, so we have to apply the product rule. So that is dy dx of px plus q multiplied by r by x plus s plus px plus q multiplied by dy dx of r by x plus s. So upon simplification we'll have, if we differentiate this, we'll have p multiplied by r by x plus s plus px plus q remains as it is. The differentiation of 1 by x is nothing but minus 1 by x square. The constant differentiation is 0. So what we have is p r by x plus ps, just multiplication, plus, so we have, so we'll have minus p r x divided by x square plus, again minus minus q r by x square. 1x and 1x will be cancelled, so this term and this term will be cancelled. So the remaining terms are ps minus q r by x square. So question 4. So that is differentiation of ax plus b multiplied by cx plus d square. So again we will have to apply the product rule. So for product rule we will have the differentiation of first term, that is d by dx of ax plus b multiplied by cx plus d square, plus, so the differentiation of second term ax plus b into differentiation of cx plus d square. So we'll have differentiation of first term is a into cx plus d whole square. So this is given by plus ax plus b multiplied by 2 into cx plus d into c. So this is because this is in the form some x square, right? So x square differentiation is 2x. So since this is another function, we'll have to differentiate it again. So that is differentiation of cx plus d is c. So now if we simplify this, we'll have a into c square x square plus d square plus 2cxd plus 2c of ac x square plus a dx plus b cx plus bd. Okay, so we can stop it here. So the next question is question number 5, that is ax plus b divided by cx plus d. I'll take this as f of x. So f dash of x is given by quotient rule. So the quotient rule says that differentiation of let's say if u is a function of x and v is also a function of x, so d by dx of u by v is given by v square. Denominator will have v square into v u dash plus u v dash. Okay, this is our quotient rule. So according to the quotient rule, we'll have cx plus d the whole square. In the numerator we'll have cx plus d multiplied by a minus ax plus b multiplied by c. So if we simplify this, we'll have acx plus ad minus acx minus bc whole divided by cx plus d whole square. So that is given by acx and acx will be cancelled, ad minus bc divided by cx plus d whole square. Sixth one, one plus 1 by x whole divided by 1 minus 1 by x. Okay, so we can simplify this equation. We can take the LCM in the numerator as well as in the denominator. So after taking LCM, we'll have x plus 1 whole divided by x minus 1 whole divided by x. So this x and this x will be cancelled. The remaining terms are x plus 1 divided by x minus 1. I'll take this as f of x. So f dash of x is given by, again we'll have to apply quotient rule, that is x minus 1 whole square into x minus 1 of 1 minus x plus 1 of 1 So this is by nothing but x minus 1 minus x minus 1 whole divided by x minus 1 whole square, plus x minus x cancelled, minus 2 divided by x minus 1 whole square. Seventh question, it's nothing but 1 divided by ax square plus bx plus c. So okay, if we consider this, so if we observe this, this is in the form 1 by something, right? So if we differentiate this, we will have 1 by minus 1 by something square. Okay, so this would be the differentiation. So treating this as in the same way, we'll have, if this is f of x, f dash of x is given by minus 1 divided by ax square plus bx plus c whole square into, now we'll have to differentiate what is inside the bracket, that is this term, differentiation of this term, that is 2x into a plus b. This would be the answer. We can also get this answer by applying the quotient rule, but that would be not necessary because we'll be getting the answer way quicker. So question number 8, ax plus b whole divided by bx square plus qx plus r. So we'll have a function of x in the numerator and a function of x in the denominator. So we'll have to apply quotient rule. So f dash of x is given by denominator bx square plus qx plus r into differentiation of numerator, that is a minus ax plus b into differentiation of denominator, that is 2px plus q whole divided by px square plus qx plus r whole square. So if we simplify this, we'll have apx square plus aqx plus ar minus 2apx square minus aqx minus 2bpx minus bq whole divided by px square plus qx plus r whole square. So this is nothing but plus aqx and minus aqx will be cancelled, and we have apx square will be cancelled with this. So upon simplification, we'll have minus apx square plus ar minus 2bpx minus bq whole divided by px square plus qx plus r whole square. So question number 9, that is px square plus qx plus r whole divided by ax plus b. So the differentiation of this is f dash of x is given by ax plus b multiplied by 2px plus q whole minus px square plus qx plus r multiplied by a whole divided by divided by ax plus b whole square. So this is nothing but 2apx square plus aqx plus 2bpx plus bq minus apx square minus aqx plus ar whole divided by ax plus b whole square. So this is given by apx square plus 2bpx 2bpx plus bq. So this aqx and aqx is cancelled, apx square and 2 will be cancelled. So these are the remaining terms, all divided by ax plus b whole square. So question number 10, that is a by x to the power 4 minus b by x square plus cos x if dash of x is given by minus 4a by x to the power 5 plus 2b divided by x cube minus sin x. So question number 11 will have 4 root x minus 2 f dash of x is, so upon we can also simplify this 4 into x to the power 1 by 2 minus 2. So f dash of x is given by 4 into 1 by 2 into x to the power of 1 by 2 minus 1 by 2 into minus 0. This is nothing but 2 x to the power minus 1 by 2, that is 2 divided by square root x. Question number 12, ax plus b whole to the power n, that is given by n ax plus b whole to the power n minus 1 into a. So we'll have to apply the chain rule, that is this is in the form x to the power n, that is nothing but n x to the power n minus 1. So multiplied by what is inside the bracket, we'll have to differentiate that again, that is differentiation of ax plus b is, this will be 0, this will be a. So question 13, that is ax plus b whole to the power of n multiplied by cx plus d multiplied by m. So this implies f dash of x is given by, so the differentiation of first term is n ax plus b whole to the power of n minus 1 into second term, that is cx plus d to the power of m, plus first term as it is ax plus b to the power of n into this will be m into cx plus d to the power of m minus 1 into c, right? So if we take ax plus b whole to the power of n minus 1 and cx plus d into m minus 1 as common, the remaining terms are n a into ax plus b plus mc into this will be cx plus d into, so this will be ax plus b. So now we have question 14, that is sine of x plus a. So the differentiation of sine x plus a is nothing but cos x plus a. 15th one, we have f of x is given as cosecant x into cot x. So f dash of x is given by the product rule, that is differentiation of cosecant is minus cosecant x into cot x. So this cot x will be outside, that is cot x, plus we have cosecant x as it is into minus cosecant x square, cosecant square x, right? So this is minus cosecant x. If I take it as common, what I'll have is cot square x plus cosecant square x. Question number 16. Cos x divided by 1 plus sin x. F dash of x is given by the product rule, the quotient rule. So that is 1 plus sin x multiplied by minus sin x minus of cos x, that is the numerator, into differentiation of denominator is cos x whole divided by 1 plus sin x whole square, right? So if we multiply, we'll have minus sin x minus sin square x minus cos square x whole divided by 1 plus sin x whole square. So we'll have minus 1 into sin x plus 1 divided by sin x plus 1 whole square. So 1 sin x plus 1 will be cancelled. So what is the answer is minus 1 by 1 plus sin x. Question 17, that is sin x plus cos x whole divided by sin x minus cos x. So we'll have to apply the quotient rule again, that is f dash of x is given by sin x minus cos x, that is the denominator, into the differentiation of numerator, that is cos x minus sin x minus, so the numerator will be as it is, sin x plus cos x. The differentiation of denominator is cos x plus sin x whole divided by sin x minus cos x whole square. So we'll have, if we take minus 1 common from the first term, we'll have cos x minus sin x multiplied by cos x minus sin x is cos x minus sin x whole square. So this is the minus that we have taken common from the first term, right? Subtracted by sin x plus cos x whole square whole divided by sin x minus cos x whole square. Okay, this is given by, so we can interchange these two, since there is a square whole square behind in the bracket, so we can interchange these two terms, right? So there won't be any difference. Even if we get a negative value, the square of the negative term will be positive. So minus sin x minus cos x whole square divided by, we will be splitting up the fraction, it is sin x minus cos x whole square minus sin x plus cos x whole square divided by sin x minus cos x the whole square. So what we'll have is, so this term and this one will be cancelled. The remaining term are minus 1 minus So we'll now expand this. Sine square x plus cos square x plus 2 sine x cos x whole divided by sine square x plus cos square x minus 2 sine x cos x. So this is nothing but minus 1 plus 1 plus sine 2x divided by 1 minus sine 2x. This will be the answer. Question number 18. Secant x minus 1 divided by secant x plus 1. So f dash of x is given by secant x plus 1 multiplied by secant x into tan x minus secant x minus 1 into secant x into tan x whole divided by 1 plus secant x whole square. So what we'll have is, if we take secant x tan x as common, the remaining terms are secant x plus 1 minus secant x plus 1 whole divided by 1 plus secant x whole square. So secant x and secant x will be cancelled. Plus 1 is 2. We'll have 2 secant x tan x divided by 1 plus secant x whole square. Question 19, that is sine x to the power of n. So f dash of x is given by, this is in the form x to the power n, that is n into sine x to the power of n minus 1 into differentiation of sine x is cos x. Question 20, we have a plus b sine x whole divided by c plus d cos x. So f dash of x is given by the quotient rule, that is c plus d cos x into differentiation of numerator is b cos x minus a plus b sine x multiplied by the differentiation of the denominator, that is minus d cos x, minus d sine x whole divided by c plus d cos x whole square. Right, so upon simplification we will have b c cos x plus b d cos square x. So we'll have minus into minus will be, all the terms will be positive, so plus a d sine x plus b d sine square x whole divided by c plus d cos x whole square. So this is nothing but, here let's see, if we take bd common in these two terms, we'll have bd of sine square plus cos square. So that is bd of cos square x plus sine square x. So this term will be tending to 1. So what's remaining here is bd. So bd plus bc cos x plus ad sine x whole divided by c plus d cos x whole square. So question 21, that is sine of x plus a divided by cos x. So we have to apply the quotient rule, that is f dash of x is given by cos x into cos x plus a minus sine x plus a into minus of minus of sine x whole divided by cos square x. So this is in the form cos of a minus b. Cos of a minus b is given by cos a cos b plus sine a sine b, right? So here a will be equal to x plus a and b will be equal to x. So this doesn't matter, we can take either way. So after applying the identity, what we'll have is cos of a minus b. A is x plus a minus of x whole divided by cos square of x. So x will be cancelled, the remaining term is cos a minus cos square x. 22, that is x to the power of 4 of 5 sine x minus 3 cos x. Right, again we will have to apply the product rule. F dash of x is given by 4x cube of 5 sine x minus 3 cos x. So next we'll have to keep the first term as it is and differentiate the second term, that is 5 cos x minus into minus plus 3 sine x, right? So we can simplify this. We'll have 4 5s are 20x cube sine x minus 12x cube cos x plus 5x to the power of 4 cos x plus 3x to the power of 4 sine x. So we can take x cube common, the remaining terms are 20 sine x minus 12 cos x plus 5 x cos x plus 3 x sine x. So question number 23, that is x square plus 1 multiplied by cos x. So f dash of x is given by 2x into cos x minus x square plus 1 of sine x. Question 24, that is ax square plus sine x multiplied by p plus q cos x. So f dash of x is, again we'll have to use the product rule, that is 2ax plus cos x multiplied by p plus q cos x plus ax square plus sine x into minus q sine x. So question 25, it is x plus cos x multiplied by x minus tan x. Again we'll have to apply the product rule, that is 1 minus sine x multiplied by x tan x, x minus tan x plus x plus cos x multiplied by 1 minus secant square x. So we can write secant square x as minus tan square x. So that is nothing but 1 minus sin x multiplied by x minus tan x minus tan square x of x plus cos x. So 26. We have 4x plus 5 sin x whole divided by 3x plus 7 cos x. So the differentiation of this is 3x plus 7 cos x. We'll have to apply the quotient rule. So now the differentiation of numerator is 4 plus 5 cos x minus 4x plus 5 sin x into differentiation of denominator is 3 minus 7 sin x whole divided by 3x plus 7 cos x whole square. So now if we multiply, so we'll have 12x plus 15 x cos x plus 28 cos x plus 35 cos square x. So next we'll have minus 12x plus 28 x sin x plus 15, sorry, this is minus minus 15 sin x plus 35 sin square x whole divided by 3x plus 7 cos x whole square. So plus 12x and minus 12x will be cancelled, and if we take 35 common in these two terms, we'll have cos x cos square x plus sin square x, that will be 1. So the remaining terms are 15 x cos x plus 28 cos x plus 28 x sin x minus 15 sin x plus 35 whole divided by 3x plus 7 cos x whole square. So question 27. So we'll have x square cos of pi by 4 divided by sin x. So we'll have x in the numerator and x in the denominator. We'll have to apply the quotient rule. So that is f dash of x is, so that will be one method, or we can take sin x to the numerator as f of x is given as x square into cosecant x into cos of pi by 4. So we know that cos pi by 4 is nothing but 1 by root 2. So that is f dash of f of x will be given as 1 by root 2 x square cosecant x. So now f dash of x is given as 1 by root 2 multiplied by 2x into cosecant x plus x square into minus cosecant x into cot x. So again if we take x as well as cosecant x outside, we'll have x cosecant x divided by root 2 multiplied by 2 minus x cot x. This will be the answer. So now question number 28. X divided by 1 plus tan of x. So again, quotient rule, f dash of x is given by 1 plus tan x into 1 minus x into secant square of x whole divided by 1 plus tan x whole square. So this is the answer. So now question number 29. It is x plus secant x into x minus tan x. So f dash of x is, we'll have to apply the product rule, that is 1 plus secant x into tan x into x minus tan of x plus x plus secant x multiplied by 1 minus secant square x. Again we can write this secant x as minus tan square x, so that is nothing but 1 plus secant x into tan x multiplied by x minus tan x minus tan square x of x plus secant x. So the last question is x divided by sine to the power of n into x. So if we apply the quotient rule, we'll have sine to the power of n x as it is, and differentiation of x is 1 minus x into n sine to the power n minus 1 of x into cos x whole divided by sine to the power of n x whole square. So this is nothing but, so if we take sine to the power of n minus 1 as common, what we'll have is sine x minus n x cos x whole divided by sine 2n x. So we'll have sine x minus nx cos x divided by sine x to the power, that is 2n minus n plus 1, that is n plus 1, sin x to the power n plus 1.